Hello everyone, welcome to iTVLK, and now we are going to discuss the questions under the theme probability. So let's move on to the question given on the paper 2018. Okay, the first question is, in a bag there are 6 identical cards, a multiple of 5 out of the first multiples of 5 is written on each card. So suppose you have a bag and you are going to put 6 identical cards and you are going to write a multiple of 5 on each card, and these multiples are the first multiples of 5. So what are the first multiples of 5? They are 5, 10, 15, 20, 25 and 30. These are the numbers which are written on these cards. Now they tell a card is taken out from the bag at random and noted down its number and returns it back to the bag and repeats this process once more. So you are going to take one card out and note down its number, and you are going to put it back to the bag, and then only you are going to take another card and note down its number. The first question is, show the sample space of the above experiment on a grid. So it is very easy. We are going to replace the card, and to draw the sample space we are going to draw 2 axes and name it as first take and the second take. So I have marked crosses. That means if you take the card which is written 5, which is their number 5, you can take the same card at the second instance also, because you are going to replace this card. So likewise, I have marked all the possible outcomes of this experiment on the grid. So this is the sample space and I have expressed it on a grid. The second question is, on the grid, encircle the event of getting a card containing a multiple of 10 on both occasions and find the probability of this event. So you have to encircle the event of getting a card containing a multiple of 10. So what are the multiples of 10 on these cards? They are 10, 20 and 30. So you have to encircle. If you take 10 on the first chance, you can take 10 on the second chance. If you take 10 on the first, you can take 20. If you take 10 on the first, you can take 30 on the second card. Likewise, there will be 6 such outcomes. And if I name this event as C, you have to find PC. That means the probability of getting the multiple of a card containing a multiple of 10 on both occasions. So to find PC, you have to divide NC by NS. What is this NC? Number of elements of this event and number of elements in the sample space. The number of elements of this event is 9 and the number of elements in the sample space is 36. Therefore, the simplest form, when you simplify 9 over 36, the simplest form will be 1 over 4. Therefore, the probability of getting a card containing a multiple of 10 on both occasions is 1 over 4. If the part B is, if in the above random experiment, the second card is taken out without replacing the first card. If event A is getting only the multiples of 5 and event B is getting only the multiples of 10. Now what do they say? You are not going to replace the first card and you are going to take the second card. So in the first occasion there will be 6 cards in the bag, and on the second occasion there will be only 5 cards inside the bag. And they tell the event A is getting only the multiples of 5. So it cannot be a multiple of 10. So what are those numbers? It can be either 5, 15 and 25. The event B is getting only the multiples of 10. They are 10, 20 and 30. The first part they ask is, using the above information, complete the following tree diagram. They have given an incomplete tree diagram indicating the first take as the events are A and B. You know there are two occasions, the first take and the second take. So I'm going to expand this tree like this, and on these lines I have written the probabilities. Look at the first take, there are two instances, if it can be either event A or B. There are 3 cards with only the multiples of 5 and 3 cards with only the multiples of 10. Therefore, the probability of getting only a multiple of 5 is 3 over 6 and the probability of getting only a multiple of 10 is 3 over 6. So, once you are completing these tree diagrams, you have to write down the probabilities also. So, suppose you have taken a multiple of 5 in the first occasion and you are not going to put it back. Then in the second occasion, it can be either A or B, and if you have taken a multiple of only 5 in the first occasion, now there can be only 2 cards having only the multiples of 5. Therefore, the probability of getting only a multiple of 5 in the second take is 2 over 5, and the probability of getting only a multiple of 10 is 3 over 5 if you take a multiple of 5 in the first take. Now suppose you are going to take a multiple of only a multiple of 10 in the first occasion. That means you are going to take either card 10, 20 or 30 outside. Now one card is missing, and because you are not going to put it back and only 5 cards are there, out of these 5 cards, 3 cards contain only the multiples of 5 and 2 cards contain only the multiples of 10. Therefore, the probabilities will be 3 over 5 and 2 over 5. Now, using the tree diagram, find the probability of obtaining a multiple of only 5 on one occasion. So, you have to find the probability of obtaining a multiple of only 5 only on one occasion. That means you cannot obtain a multiple of 5 on both the occasion. That means you cannot take this PAA because it has in the both occasions we have taken the multiples of 5. So, you have to obtain the probabilities PAB and PBA. So, you know when you go along these lines, you are going to multiply the probabilities. So, PAB will be 3 over 6 into 3 over 5 and PBA will be 3 over 6 into 3 over 5. So, when you simplify this, you will obtain 18 over 30. The simplest form will be 3 over 5. Now, the question which appears in 2019 paper is, a bag contains 6 identical balls numbered from 1 to 6. A ball is taken out at random, the number is noticed, and then another ball is taken out at random without replacing the first ball. So, there are 6 identical balls and they are numbered from 1 to 6. You are going to take a ball and note down its number, and you are not going to put it back. So, first they ask to represent the sample space of the above experiment on the grid. So, here if you take the ball which is numbered 1 in the first occasion, you cannot obtain the same ball because we are not going to replace it. Therefore, we are not going to draw crosses along the diagonal since those balls are not in the second chance. So, this is the sample space of the above experiment, and I have marked crosses to indicate the events. Enclosed in the grid, the event that the sum of the two numbers obtained is greater than 7 and find its probability. So, you are going to take 2 balls out at 2 occasions and you have to encircle the event of getting the sum of these two numbers greater than 7. That means if you take, suppose you are going to take the balls 1 and 6, the addition will be 7, but it is not greater than 7, so you are not going to take it. Now look at the ones that I have encircled. First I have encircled 2 and 6, the addition will be 8. 3, 5, the addition is 8. 3, 6, the addition is 9. 4, 5, addition is 9. 4, 6, addition is 10. 5, 3, addition is 8. 5, 4, addition is 9. 5, 6, addition is 11. 6, 2, addition is 8. 6, 3, addition will be 9. 6, 4, addition is 10 and 6, 5 is addition is 11. So these are the outcomes of this event. So if I name this event as A, you have to find PA. It is equal to NA over NS. NA means the number of elements in this event. It is equal to 12. There are 12 circles. And NS is 30 because there are 30 crosses in this grid. Therefore, the final answer will be 2 over 5. The probability of getting a number, getting the sum of these two balls is greater than 7 is 2 over 5. Now, the third part is considering the event of getting a number greater than 4 as A and getting a number less than or equal to 4 as B, complete the following tree diagram. So, this is the incomplete tree diagram they have given. There are two events A and B and they tell A is the event of getting a number greater than 4. So, what are the numbers greater than 4? They are 5 and 6. The numbers which are less than or equal to 4 are 1, 2, 3 and 4. Therefore, in the first take, there are 2 balls numbered greater than 10, greater than 4 and 4 balls numbered less than or equal to 4. So, I have written the probabilities. It is 2 over 6 and 4 over 6. Now, suppose you have taken a number which is greater than 4 in the first occasion. So, now you are not going to replace it. Therefore, there is only one number inside the bag which contains a number greater than 4. That can be either 5 or 6. We don't know it. So, the probability of getting a number greater than 4 in the second take is 1 over 5 and greater than, less than or equal to 4 is 4 over 5. Now, suppose you are going to take a number less than or equal to 4 in the first take. Now, you are not going to replace the ball. Therefore, only 5 balls are there inside the bag. And out of these 5 balls, 3 are less than or equal to 4 and 2 are greater than 4. Therefore, the probability of getting a number greater than 4 is 2 over 5 and less than or equal to 4 is 3 over 5. So, this is the completed tree diagram. The fourth part is, using the tree diagram, find the probability of getting a number greater than 4 at least once. That here they have asked the wording at least once. That means either you can take it on both occasions because they tell at least once. That means getting a number greater than 4. That means you can take PAA, PAB and PBA. So you have to add these probabilities. So to find PAA, you have to go along these stems, and you know when you go along these stems, you are going to multiply the probabilities. So to find PAA, I have multiplied 2 over 6 by 1 over 5. To find PAB, I have multiplied 2 over 6 by 4 over 5. And to find PBA, I have multiplied 4 over 6 by 2 over 5. So when you simplify this expression, you will get the final answer as 18 over 30. The simplest form will be 3 over 5. Okay children, so that's the end of the discussion of 2 questions regarding probability, and we'll meet up in the next session regarding number patterns. Thank you.